What we're doing is trying to make new vaccines that can be inhaled. They're dry powders, and we disperse them and we inhale them, and in that way we can immunize people. The goal of this is to get rid of needles and syringes because A, they hurt, B, they transfer occasionally infections if the needles are reused, as they sometimes are, even though there are strict rules against this in developing countries. Countries are so poor, they try to recycle everything and try to clean as best they can. But an inhaled form of vaccine is intrinsically safer, intrinsically better if you dispense the vaccine in individually packaged blisters, as we'll show you here. It looks like he's loading the powder containing the blister into a disperser, a little plastic disperser. He's attaching a bulb that's just a squeeze bulb with a special valve that turns inside out as soon as you pressurize at 2 pounds per square inch, and that blasts faster the powder apart into its microparticles and nanoparticles, which then are small enough that they get in through your nose or mouth, through the trachea, into the lungs, and where they then induce an immune response. David's going to pop the valve, and now the bag is full of aerosol, and as you can see, it's beginning to waft out, and there's a very nice plume of powder that is in the bag. We would normally suck from that bag and empty it in that way if you're an adult. If you were an infant, you would put the bag on a mask so that the mask would then confine the powder and they would breathe for about 30 seconds. The World Health Organization and the Latin American Foundation and UNICEF and other individual donors to vaccine programs globally only have a certain amount of money that they can afford to spend per dose on giving away vaccines to people in poor countries. And for measles, that's surprisingly inexpensive. We had to really meet a very low cost point. So we cannot spend more than 10 cents for the device and 17 cents for the dose, per delivered dose, or it can't be commercialized. And we want it to be commercialized, and we're pleased that we've been able to meet that cost point.
I was interested in the atmospheric analytical program and looked through there, but was really excited about using particles to benefit mankind, to help save children with vaccinations. That's the whole measles project really got me in here. As far as characterization, using analytical techniques to characterize a vaccine that is going to save lives.